Welcome to The Explainer. Today we're jumping into a pretty wild idea. It's a concept that basically flips our whole understanding of reality on its head by asking a truly massive question. I mean, for centuries, the answer to that seemed pretty obvious, right? We've always kind of pictured the laws of physics as these perfect, timeless mathematical truths. These unchanging rules that were around even before the Big Bang, and they'll be here forever, just waiting for us to stumble upon them. And look, this traditional view, what people call the Platonic view, it's neat, it's intuitive, but here's the thing. The universe itself seems to be telling us a totally different story. It's like it's been leaving this trail of breadcrumbs for us, and they point to something way, way stranger. So, what if the laws of physics weren't discovered at all, but they survived? Okay, let's really dig into this because we're about to explore a revolutionary idea that the laws running our universe aren't some kind of pre-written command. Nope. They're actually the survivors, the winners of a cosmic scale survival of the fittest. But before we get there, we've got to understand the idea we're up against. So first up, let's tackle the eternal laws myth. So in this view, things like gravity or electromagnetism, they're not inventions, right? They're just part of the bedrock of reality. Asking why we have these laws? Well, that would be like asking why 2 plus 2 equals 4. It's a meaningless question. They just are. But, that really clean picture started to fall apart when physicists started looking really closely at the numbers, the fundamental constants that are basically the universe's settings. And what they found was, well, it was incredibly weird. So take the cosmological constant. This is the thing that controls how fast the universe expands. Its value is so precise that if you just nudged it a tiny, tiny bit, we're talking a number so small it's ridiculous. The universe would have just blown apart too fast for any galaxies or stars or planets to ever form. Game over before it even started. And this isn't just a one-time fluke. Look at the Higgs mass. Our best theories predict it should be absolutely massive, like insanely heavy. But what do we actually observe? Something that is quadrillions of times lighter. That's not just a small error. That's like expecting a bowling ball and getting a feather. Something is definitely up.
And this just shows what a knife's edge we're living on. Look at the strong nuclear force, the glue that holds atoms together. Tweak it down by just 2%, and the only thing in the universe is hydrogen. No heavy atoms, no complexity. Okay, now tweak it up by 2%, and all the hydrogen would have been cooked into helium right at the start. That means no stars like our sun, and for sure no water. Either way, we're not here.
So this whole fine-tuning puzzle kind of leaves us with 3 ways out. First, you could say it was designed that way. An intelligent creator set all the dials just right. Hard to test that one. Second, you could say we just got insanely, unbelievably lucky, which, I don't know, just feels a bit unsatisfying, right? But that third option, selection, now that opens up a really fascinating door. It suggests, hey, maybe we're not special. Maybe we just happen to be in one of the universes where it's possible for observers to exist and ask these questions. And that idea is exactly what brings us to our next section, a Darwinian universe. We're going to take that idea of selection and blow it up to the scale of the entire cosmos. There's this theory, it's called cosmological natural selection, or CNS, and the idea is pretty mind-bending. It suggests that every time a black hole forms, it actually creates a brand new baby universe. And this new universe gets its parents' laws of physics, but with little random tweaks. Think of them like cosmic mutations. So you see what's happening here. You get a cosmic version of evolution. Universes whose laws happen to be good at making lots of black holes, well, they have more kids. So over countless generations of universes, the whole multiverse would naturally start to fill up with universes just like ours, ones where the physics is perfectly tuned for making stars that collapse into black holes. Okay, but here's what's really wild. You don't even need to believe in a multiverse to see this Darwinian logic playing out. It seems to be happening at every single scale of reality, right here in our own universe. Let's take a look. Let's zoom way down to the quantum level. There's this idea called quantum Darwinism. The quantum world, as you know, is this fluffy, chaotic soup of possibilities. So why do we see solid, definite things like a rock or a tree? Well, the idea is that those objects are the quantum states that are tough enough to survive. They survive being constantly measured by everything around them. And not only do they survive, they actually make copies of their information, broadcasting it out so we can see them. They literally reproduce their information.
Or think about it from an information point of view. A physical law, like, say, energy is conserved, what is that really? It's just a super efficient shortcut, right? It's like the ultimate zip file, compressing a ridiculous amount of data about how the universe works into one simple sentence. So maybe the laws that survive are just the ones that turn out to be the best compression algorithms for our reality.
And this goes for fundamental particles, too. They're survivors. The whole particle zoo is really just a list of what's stable and what's not. I mean, an electron seems to last forever, but a Higgs boson, poof, it's gone in a fraction of a second. So why the difference? It might come down to something called topology. The really stable particles, like the electron, could be like a persistent knot in the fabric of space-time itself. Their very shape protects them and keeps them from just unraveling. Okay, so let's recap. We've got survival of the fittest for whole universes, for quantum states, for information, even for particles. This brings us to the next section and to the really big question that's been lurking behind all of this.
I mean, in biology, nature is the selector, right? In quantum physics, it's the environment. So what's the ultimate selector for the laws themselves? What's the final judge that gets to decide which set of rules gets to run a reality?
And the proposed answer is, well, it's both really deep and surprisingly simple. It's the need for observers to agree. A physical law gets to survive if, and only if, it lets different people, different observers, look at the same event, compare notes, and actually agree on what happened.
Think about that for a second. That totally flips our understanding on its head. It means that a fundamental law, like the one saying the speed of light is constant for everyone, that's not some top-down command from the universe. No, it's a precondition for us to have a shared reality at all. It's one of the rules you need so that your experience and my experience can line up. Without these kinds of rules, reality would just be an incoherent, jumbled mess where nobody agrees on anything.
Which brings us full circle to our final section and to this really powerful new way of thinking, laws that simply work.
So let's put it all together. We started with that classic, intuitive idea of eternal laws that we just discover. Then we got this surprising hint from the universe's fine-tuning that suggested, hey, maybe things could have been different. And that leads us to this totally new way of looking at it. Laws aren't discovered truths, they're emergent protocols. A great analogy is TCP/IP, the protocol that runs the internet. It's not a law of nature, right? It's just a set of rules that stuck around because it works. It allows all our different devices to have a consistent shared conversation.
Thinking about physics this way, as an emergent evolutionary system, is a massive, massive shift. And it leaves us with one last, kind of provocative thought to chew on. If the fundamental laws of physics are just the survivors of some grand cosmic contest, what other eternal truths that we take for granted are actually just the current winners waiting to be challenged?